Okay. Yes, we are live. Hi, everyone. Welcome. Good morning, good evening, good afternoon, wherever you are. We just got here, the awesome Josh Long. And, well, go straight to the point, Josh. Thank you very much for your time. I
I'm
know you
sorry for
are,
being so delayed.
no problem. I know you are busy right in Belgium for DevOps. And we really appreciate that you make your time to be with us. And the word is with you. And thank you very much again.
Thank you. Thanks for having me. Do I just share my screen then?
Yes, whatever you.
Okay.
I will monitor the chat. If you have some questions, I will let you know.
Okay, let's do this. I'm going to share my screen. Okay. And then hide the cam. Okay. Can you see my screen and only my screen, I hope?
Yeah, actually, yes. I can
Okay,
see also myself, but yeah, and now just your screen. Yes.
okay. Good stuff, my friends. So today we are going to talk about testing. We don't have a lot of time, so I appreciate that you all are here today. It's appreciated. Let me open the slides here. I always forget these slides. Presentation.indd. Here we go. Okay. Okay. Oops, they just updated the software I used to present, so I'm going through that churn ever so briefly here. I'm sorry about that.
No problem.
I mistakenly use sometimes the Adobe suite of products to do my presentations, and they updated everything. Okay, so very good. We have very little time. Let's say it's what time is it now? It's 3:44. So I reckon we're gonna go till about 4:44 local time in Belgium here. 15:44, so 16:44. So with that in mind, take note of this Git repository. Here you're gonna find all the code that you will need to be able to follow along later on. Of course, you'll find my Twitter if you want to send me a direct message or anything else. I'm happy to talk, and you'll find my email, so you can ping me there that way as well. I work on the Spring team. I do training videos. I've got a book I wrote. I've got a podcast every Friday called a Bootiful Podcast. I write a blog every Tuesday called This Week in Spring. I publish a screencast every Wednesday called Spring Tips. And I'm running a new book called Reactive Spring. And this book is all about how to build reactive applications that take advantage of asynchronous, sort of non-blocking I/O, right? And we're going to use some of that today. We're going to see some of that. There's actually a whole discussion in this book about the stuff that we're going to talk about today as well, because we are going to use reactive programming, but I'll ever so briefly introduce that soon. What we're going to talk about is testing, right? Testing is a very important thing that we do for our software, and hopefully I don't have to convince you, my friends, of the benefits of testing, right? I hope that at this point in our lives that we are all writing tests for our software, but I don't know that, right? We don't know. We can't take that for granted that we're all writing tests for our software. All I know for sure is that you should be. What I hope is that by now, 2020 almost, you're all writing tests. What I may not be so sure about, what I'm not so sure about, is whether you're all writing tests first. And this is what we're going to kind of focus on today. The goal of writing test first, test-driven development, is not a new idea, not a new goal by any stretch, but it's a worthy one. And I want to introduce a few reasons why. First and foremost, test-driven development helps you focus on writing code that can be tested. And I know that's sort of self-defeating or self-describing. Obviously, if you write the code first, if you write the test first, then of course the code that you write that follows that test is testable. But think about what you need to do when you write testable code. You need to create clean objects that have well-known constructors and well-known injection points, so you can swap out collaborating dependencies. So in this way, you end up creating cleaner code, more object-oriented code, right? You're not going to use private auto-wired fields, for example. That's very untestable. This benefit here is that you write more elegant code, more object-oriented code that is easier to test. So you actually get a better code by writing the test first. There's some other benefits too, though. Most of us think about testing as a sort of a chore. It's a thing that we do at the end of the process after we finish the code. And we all experience this sense of satisfaction, the sense of joy that we have succeeded in finishing or implementing a particular feature. And then we say, oh, now I have to write the test. Oh, why? I don't want to do the test. I've already got the thing working. It works on my machine. And you have that sense of euphoria, that sense of joy in making the software work. And then it disappears because now you realize you have to now write the test to prove what you already know to be true, which is that it works. This is a very depressing, dispiriting moment in the software development lifecycle. I think a lot of us confront or embrace documentation as a similar sort of chore. It's work that needs to be done, but that's not really fun to do. So what we're going to talk about today is why we can get around that, why test-driven development helps us have fun. It doesn't take away the fun. And the principal reason for this is because when you write the test first, by the time that test is green, you've also succeeded in delivering the production software. That's the code that can be deployed into production. So you get 2 for 1. The moment the test is green, so too is your feature delivered. So now you've only got one moment, and at this point, you've got 2 things done. Once you've delivered on that, you feel better, right? It feels, everybody likes to feel like they're achieving something. In fact, our brains are wired for this. They're built to absorb or to anticipate successes, wins that are coming up. They look at things like video games. People like video games, and that's because they're designed to be addictive. They create a sense in our brain that if we just keep working a little bit more, if we just keep going just a little bit more, we will be able to get to a point where we have succeeded in beating this next level or the next boss or whatever, the next character, the next puzzle, whatever it is, right? If you just keep going a little bit more, you'll get there. And eventually you do get there. And it doesn't take too long, right? If it takes too long and if it feels impossible, well, then our brain has a bad reaction to that. It can be very frustrating to play a game that doesn't ever get beaten, that you can never beat, that nobody can ever beat, right? So we've seen people actually commit self-harm if they play video games that they can't beat. It's too difficult, right? So the goal is to not create games that are so hard that people can't do it, but it's also important to create games that give you a sense that if you just keep going a little bit more, you'll get somewhere. And of course, if you do this, you get addicted, right? This creates an addiction in the brain. Same thing for people who jog, right? If they go for marathons and things like this. Jogging is not an intrinsically a fun thing to do. It's not something people enjoy doing by themselves. What's fun about jogging is that they have a sense of, hey, if I keep going, I'm going to get to this next milestone. I'll beat my record. I'll make faster time. I'll get to the next horizon. I'll get to the next landmark. This is an inherently satisfying experience. People love to feel like they're making progress. They're moving towards a horizon. And the same is true for testing. When you have constant feedback from your code, that the test is green and you're making progress, you're making more progress, you're getting towards a milestone, that feedback is very satisfying. People like that. In fact, all of these different things I've just described, all these different acts, they create in our brain a sense of satisfaction. And that sense of satisfaction is what we crave. Our brains become addicted to it. It's the reason that people like us, people who are creative, people who sit in software, people who sit and do art, people who do video games, people who jog, all these people have the ability to get into what we call the zone. And you've, I'm sure, heard about people talking about this, right? You've heard people say, oh, well, I started coding at 9 o'clock in the morning. And then the next thing I know, it was 9 o'clock at night. What happened? Where did the sun go? It was just all day, super quick, right? And that's because you get into the zone. You sit on the computer and you write code, and the next thing you know, the day is gone, but you've gotten somewhere. You feel like you've changed the world. You've done something amazing. You're going to deliver that feature that everybody wanted, right? That feeling is the best thing in the world. A lot of us don't like it when we go to an organization and they take away that fun, right? That joy. Just because, in the same way that video games that are too hard to win are very dissatisfying, they're very frustrating. It can be very frustrating to start feeling like you're making progress and then to have somebody interrupt you, right? This is why people who work in organizations that are bothered with constant meetings are so unhappy. It's so sad too, because software development is a very fun thing to do. If you're any good at it, and I'm okay at it, right? If you're any good at it, then it's a very satisfying, very pleasant thing to do, unless you have somebody constantly interrupting you. Then it can be very, very dissatisfying, right? Just like very hard video games. You constantly get close, but you never get there. It's very, people get upset about that. So test-driven development gives you that sense of, hey, I'm making constant progress. All these little green tests, that shows me I'm making progress. I'm winning. I'm succeeding. I'm making it to the next milestone. And the further I go, the more success I feel, right? The more satisfaction that I feel in my work. This is a wonderful, virtuous feedback cycle, and that's what we're trying to capture when we do test-driven development. Now, when you do test-driven development, there's a couple of ways to think about your system, right? How do you start test-driven development? Well, first of all, keep in mind that while I am just one person, and I'm going to do test-driven development by myself today, a very nice way to do test-driven development is with somebody else. You can pair program. You can sit there, two people to a computer, or rather, two people, two screens, two mice, two keyboards, but one computer, right? You can sit there and pair program. And in this arrangement, perhaps one of the pairs, one of the people in the pair, will write the will write the test code that is red, that is failing, okay? So I write a simple test that asserts something about the state of the system. My pair writes the production code to make that code work. And so you go back and forth, you ping pong. This is called red-green refactoring, or red-green ping pong, right? So what I'm doing is I'm writing red code, and then somebody else writes the green code writes the production code to make it green. And as soon as it's green, then I write some more red, and then you write some more green, and we go back and forth like this, constantly moving forward. That's also a very satisfying way to work. As you're going to see today, I can do it by myself, and you can do it by yourself. It's not hard. I'm just saying you should try it with somebody else. It's very fast. It's also very satisfying, and it keeps your mind engaged because you're constantly having this creative process with somebody else. Now, the question then is, how do I decide where to start when I do test-driven development? Obviously, we should test first, so that's the first part, but test what? In a given system, there's a lot of things you have to do to build software. And it sort of depends on where your risk is, I suppose, in deciding what you want to do to write your tests and write your projects. Let's suppose you want to build a typical sort of a microservice. Microservices, at the end of the day, have HTTP APIs or RSocket APIs or gRPC APIs. That's the integration point. That's the endpoint. It's the closest thing to a user interface that you have in a microservice. Obviously, if you're building a monolith, then the user interface is also an endpoint, right? That's the thing that people integrate with. Integration carries a lot of risk, especially for particularly complex services and systems. So that integration, if that's risky for you, might be a thing that you want to focus on first. This is particularly useful in an environment where you have two different teams working together, right? You have two different teams trying to build something in isolation, independent of each other, and they're going to integrate at the end. So perhaps you as an organization can say, okay, this team is building the order service, this team is building the customer service. There's an integration that has to happen at the end. That integration is very, very risky. There's a lot of unknowns there. There's a lot of things that we need to sort out in order for this to be successful. You can decide, okay, if the integration between these two things is risky, then perhaps we as two different teams should focus on that first up front. In this case, you're building the integration, the API first, and then you're building the components and the services and the controllers and the entities and the DAOs and whatever, all that stuff below the API. You're building all that afterwards. So what we say is when you build outward and you work your way inward, that's called outside-in testing. And you might do this if you're concerned about the integration layer between two different APIs. The problem with this approach, it's not a problem, but the cost of this approach, the trade-off that you make when embracing this approach, is that you have to say that I deem the integration to be more viable than the independence of these two different teams. Remember, if you focus these two teams on integration up front, then that's the first thing they have to do. And there's no chance for them to experiment or to explore their individual domains for a little bit to get a better sense of what needs to be done below. And in the meantime, they're also in lockstep. They must be working together, okay? If you want your teams to work independently of each other without having to work in lockstep, then you can have them work inside out, right? They can start with the small stuff, each side working on the database and the services and the controllers and transactions and all that kind of stuff until they eventually get to the API. In this case, you're valuing the independent autonomy of these two different teams over the de-risking of the integration layer. what approach you choose is entirely up to you. There's no wrong answer here. I just want you to be aware of these possibilities. In our case today, we're going to build a very trivial API. So we're going to start inside out. And I'm not too worried about the integration of these services later, but you could certainly do that, as you're going to see soon. So in order to build some software, we're going to do my favorite thing. We're going to go to my second favorite place on the internet after production, start.spring.io. And by the way, I'm in dark mode here, but you don't have to go to dark mode, right? This is one of the nice things about start.spring.io. So I'm going to go to start.spring.io, and I'm going to generate a new service called, let's just call it Producer, okay? And when I go to Producer, I'm going to build a new application. Obviously, I have some choices to make. You have the first kind of choice is what version of the JVM would you want to use in 2019? I'm going to choose jar, right? That's the latest and greatest. And then, of course, the choice of packaging. The choice of you have the choice of packaging. I'm going to choose jar. Then you have the choice of Java. Which version of the JVM do you want to use? Here, my friends, there's a couple of answers here. There's three answers here. Only one of them is wrong, and I would say that's Java 8. You shouldn't be using Java 8 anymore. If you want the long-term supported edition of Java, you should use Java 11. If you're on a cloud platform like Cloud Foundry, Pivotal's Cloud Foundry, or you have somebody operating the platform for you, and it's just not a risk that you have to worry about, then you should be on the latest and greatest version of Java, right? Java 13. If you can be sure that you can effectively automatically roll forward to the next version of Java, then you should be on the latest version of Java. This is very easy to do in modern cloud platforms, right? So they manage the version of Java for you, in which case you're just using the latest and greatest one. So I would stick to that if I could. But if you're deploying and manually racked and stacked servers with infrastructure and old data centers, etc., then of course you want to stick to a more reliable, more trusted, more secure, well, not more secure, but at least more supported version of Java, like Java 11, okay? I'm going to stick with Java 13 because I do all my work in the cloud these days. Anyway, and then we're going to build an application. We're going to build an application that takes advantage of reactive web programming. You won't need to know too much about reactive programming to appreciate all this, but we'll cover that. We're going to use Lombok, which is a compile time annotation processor that makes working with the Java just a little bit less boilerplate, a little bit less verbose. We're going to bring in the reactive MongoDB support here. So reactive MongoDB. And we're going to bring in the Spring Cloud Contract verifier, okay? I'm going to hit generate, and that'll give me a zip file that I can open up here in my IDE. So here we go. There's this. And to save bandwidth, I'm going to go back to hiding my cam since that no longer is needed. Okay. Okay, so we now have this project. Hopefully it's opened yet. There it is. Okay, it's downloading the internet. I'm on reasonably fast Wi-Fi here in Antwerp, Belgium, but you never know. All right, so we have a public static void main entry point into our application. And this is not where we're going to start. Let me make the font bigger, just a little bit bigger here, my friends. Okay. All right. Okay. And voila. So there's my test. Now, but this is going to use by default JNet 5. You can certainly do that. But I think most of us are perhaps familiar with JNet 4. So to make this a little bit more applicable, I'm going to remove the JNet 5 dependency. I'm going to re-enable JNet 4, basically. So that's all I have to do for that. And with that done, I am still given this JNet 5 test. This is a nice existing test. When you generate a brand new project on start.spring.io, it knows that it's 2019, and in 2019, all of us should be writing tests. So it adds the test support no matter what. We don't even get a chance to say no. We must have the test support. It then generates a test class. Now, I appreciate the effort. It's a nice gesture, but this is actually not a very good test. So we're going to delete that test, and we're going to start simpler, okay? The first thing I'm going to do is I'm going to create a test to confirm that I can create a simple POJO that maps data correctly, okay? So here we go. Add test public void. And I'm going to create a test that saves data. And this test, actually, it's not going to save data. It's just going to create an instance of an object. And I'm going to create an object called a reservation. Reservation, here we are. Okay, new reservation. And my reservation is already failing, right? I'm not sure if you can appreciate that, but I've got red ink on the screen. It's compiling and it's failing to compile. That is a test failure. So already I can't move forward. I have to write production code because I've got red code. I've got red tests, basically. I now need to create some production code to make it green again. Simplest thing I can do is create that entity, that type. Good. I've got a MacBook Pro, and my N key is stuck. So sometimes you'll see me type like that, and I don't mean to. It's just this goofy keyboard. Okay, so there's that. Now you can see the constructor is broken, so I need to create that as well. I could do this the old-fashioned way. I could say I want that done that way, but what I'm going to do instead is create getters and setters using Lombok. So I'll just do that here at data, at all args constructor, at no args constructor. Okay, voila. There's my DTO, my entity, if you will. Okay, so now if I'm going to go to my test, all I'm trying to confirm is that when I poke at this object, I can confirm that it matches the state that I'm expecting. So I can say assert equals reservation.getName equals Jane, and get ID equals 1. Okay, so very simple stuff. You've seen this before. These methods have been on the assert class for decades, right? Literally probably 20 years, closer to 20 years than not, right? Been around for a long time. But there's some other ones that are kind of nice. You can also do assert not null, right? Not null reservation.getName. And you can provide an optional message. You can say, okay, the name should not be null. Okay, good. So that's a very convenient arrangement there. There's another thing you can do, though. These are very simple tests. I'm saying, oh, prove that this equals that. I'm saying, prove that this does not equal null. That's a very simple thing you can do. If you have a more complex test, then you might want to be able to capture that test in what's called a matcher. And you can do that here. You can say assert that reservation.getName, and you can use a matcher. And one of the great libraries out there that provides matchers is Hamcrest. So I can say that I want to make sure that the name equals Jane. Okay, so let's run these tests and see what we get. Okay, and there we go. It's all green. Everything's fine. So that's working, right? That's working as we expected. I like these matchers. These are great for capturing complex scenarios, complex tests that you want to validate each time. You can create your own matchers, right? So if you can go here, for example, assert that reservation.getName, and you can see the type is just matcher. So you might be tempted, foolishly, to use this interface, but you can see that when you do that, they try to communicate with us in a very subtle way. It says, don't implement matcher. Instead, extend base matcher, which I think is, a bit unfortunate, right? Especially now with Java, with the new versions of Java, you can use default methods on interfaces. So there's no reason this couldn't have been changed a little bit or something like that. But anyway, let's use base matcher. And base matcher takes a parameter here. Okay, and the parameter, okay, the contract here is very simple. It says match these two methods, describe to and matches. Okay, the parameter is ignored here. That's why that is. Okay, so we have a public Boolean matches, and it says, okay, given a string, in this case name, prove that O equals, Jane, for example. That's a very simple test. If something goes wrong, then I don't have to go through the code and debug it, looking for some cause of the error, right? The complex test that I ran, I can prove that, for example, I can say, okay, O, let's try this. Let's say instance of string and string dot class dot cast O dot car at 0 character is uppercase. So this is my complex test, right? I'm making sure that it's a string, and I'm making sure that it starts with an uppercase. If the string doesn't match, then I can say the first letter must be uppercase, okay? So I have no production code to validate that, but you can very easily create your own matchers. You can extract this out instead of doing an anonymous class, as I have done here, okay? So run that. Compiling. Good. Okay, so that's all working. All right, so now that's a very basic entity, a very basic POJO, but we haven't actually proven that it can be persisted in the database. We haven't proven that that'll work as we expect it to. So what we want to do now is write a POJO. We want to create an entity. We want to confirm that this can be written into the database. So reservation document test. Okay, reservation document test. And here, all we're going to do is confirm that when I use MongoDB, my persistence tier, my entity, my document, which will be persisted, it'll be round tripped correctly. So I'm going to take an object, I'm going to add data to it. I know that I can add data to it. I know that the state in the object works correctly because I've just tested that, right? Now I'm trying to confirm that the object can be written to a database, that it's mapped using the object document mapper that is Spring Data reactive MongoDB. I want to confirm that that's working correctly. So I'm going to say test public void persist. Okay. Now this is going to require me to create a connection to the MongoDB database. It's going to require that I have some way of persisting the data. It's going to require that I set up all of that machinery required to test just this mapping. Now that machinery is stuff that Spring already knows about. I don't want to recreate all that machinery just to test this one little thing in isolation. Well, Spring provides something called a test slice. A test slice lets me say to Spring, here, load up only the things required to support, for example, persistence. Okay, so we can use that in conjunction with a JUnit test runner. So at run with Spring runner dot class, and then here I'm going to use data mongo test. So that's my test slice. This tells Spring. This tells JUnit rather to delegate certain lifecycle operations to Spring, and this tells Spring itself to only load up the objects in the application context that are required to support persistence with MongoDB. So with that in place, I can now, for example, inject a repository. So private reservation repository. Now, of course, there is no repository. I've got red test, don't I? So I have to create that type. Here we go. Interface extends reactive CRUD repository reservation string. Okay, there's that. So it's an entity. It's a repository that's going to manage entities or documents of type reservation, whose primary key or string or document ID or whatever is string. Now in the reactive world, you can see that these things are the methods here that are provided in this interface are basically familiar: save all, flush, delete, count, etc. They return types like mono and flex. These are asynchronous. Think of them as being like publishers, right? They're super powerful publishers that are just way more powerful than anything you can do with a publisher. Flux and mono are publishers, and they both take publishers. You can think of them like futures. That's the way to think of it, actually, but way more powerful than a regular future. Okay, so I have this repository, and I don't need to actually implement that class. Spring will do that for me. So I can just inject that into my code, into my test like this. And so now I'm going to use that to write data to the database. So this reservation repository.save new reservation. Actually, I don't need to provide the ID. I want to make sure that that gets persisted and it gets automatically applied through the mapping. Okay. Now notice that I said that these are publishers. They're kind of like futures, right? They're asynchronous values. So I need to verify that I have gotten the value that I expect asynchronously. I could actually what's called subscribe. I could actually sit there and wait for the value to arrive, but that would happen in a different thread, and that wouldn't be the same thread as my test case. So I need to make sure that I can, serialize that, so I can actually poke at or I can assert certain things about the state of the data. So I'm going to say, pass that in, step verifier. I'm going to expect that the next result that comes back, the one saved object that'll get result returned, is this. I'm going to say reservation.getName equals ignore case Jane, and reservation.getId name, what else do I want to do? Is not null. I guess I should have done this first, right? That would be more natural. So that's my simple test. I'm trying to prove that the name is Jane, and actually I want to confirm the ID is not null. That's actually a more useful test, isn't it? So there we go. There's my simple test. And once that's done, I just want to verify that it's complete. So I will say, save the data and verify that the name is what I expect it to be, and verify that the ID is not null. Let's see if that works. Run this test. Okay, that's the POJO. I need to run the test for the document persistence. There we go. Okay, so we can see the test has run, and it's green, super quick, right? I was able to get the whole just the persistence tier up and running very quickly. So I can run it again, and it's compiled now. So there we go. There we go. We got the data that comes back. Okay. Now, this is a very useful technique. The step verifier makes it very easy to test reactive code, right? This is why, as I said earlier, I've got this covered in my book. Now, I want to now confirm that I can build an HTTP endpoint, and I want to confirm that that endpoint returns the right JSON given an appropriate request. So let's create a reservation HTTP test, and we're going to say at test public void get all reservations, throws exception. Okay, and what I'm going to do here is I'm going to use the web test client. This is the reactive web test client that allows you to test HTTP endpoints. It's going to be run with, of course, Spring Runner class. Okay, and we're going to use a different test slice. In this case, we're going to use a WebFlex test. So WebFlex is the name of the reactive web framework that we're using to create web services here, HTTP endpoints. And it's going to load up only the things having to do with the HTTP tier. Most importantly, it's not going to load up the database tier. Nothing in the Spring application context that supports talking to the database will be instantiated in this example. So let's say webtestclient.get.uri HTTP localhost /reservations. Okay, so I'm just creating a HTTP GET request, and I'm asserting that when the data comes back, I expect the body to have a certain structure. I'm going to assert that structure by using a JSON path expression. Okay, so there's this. I want to expect that the status, status is okay. It's going to be 200, right? I'm going to expect that there's a header, and that the header matches content type application JSON. Okay. So there's my web test client, and there's my code. We should see that this is going to fail for a number of reasons. Obviously, I haven't even written the HTTP endpoint, the HTTP service, so that's not going to work. Let's do that. We can already see it's going to fail, right? There you go. So let's build reservation HTTP configuration. In the production code, this is just a regular Spring configuration class. It contains beans. The bean I'm going to define here is a router function. To server response, okay? Routes. In order to do this, I'll return route.build, okay? .get /reservations new handler function. All right, so there we go. There's my response. So in order to provide that response, I'll say server response.okay.body, and I'm going to inject my collaborating object, my repository. I'm going to defer to that to make this work, right? Obviously, but of course, keep in mind, I've already just said that this won't work. I'm not going to have anything related to the data tier in my application context. So that sets us up for the next problem, the next thing we need to confront here. I've got a functional reactive HTTP endpoint. It lives in this configuration class. I'm going to bring it into the test like so. Okay, and with that there, I'm already almost done, and yet I can see a problem. Let's just run it and see what we get. Okay. Okay, so there we go. You can see it failed. It says we can't find the bean of type reservation repository. There we go. That's awkward. So we need that repository, and yet we don't have it because we created only the web tier. The WebFlex test only creates the web test web machinery, right? Nothing else. In order to make this work, we need to mock out that collaborating object. Now I could create a configuration class and then include that configuration class just for the test, and then have a Mockito mock defined bean in that configuration class. But that's it's a fair bit of extra work. What I really want to do is just have a shortcut to say, hey, please replace any type of this interface, any bean of this interface or this type in the application context. If it doesn't exist, then go ahead and just add it to the application context. So either replace it with a mock or add it if it already does exist, or if it doesn't exist, I mean. So we can do that with @mockbean. @mockbean is a Spring Boot annotation, but behind the scenes, all it does is use Mockito. So you get a standard Mockito mock, like so. It's just that it has the extra shortcut of also replacing it in the application context. So now, I said I wanted to use a mock. I don't actually want to use a mock. I want to use a stub. A stub is a thing that responds in a pre-programmed way. It provides default values, whereas a mock is just sort of an empty object. A mock is a thing that takes a place for something. It's an object that returns null or zero or false. It's an empty husk, if you will, in your test. But it's not actually a thing that responds in any particularly meaningful way. We need a stub. So we're going to actually stub out this behavior using standard Mockito behavior here. So we're going to say, when we call find all, then return flux.just, right? And I'm going to produce a new response, a new reservation with the result 1 and Jane. Okay. Good stuff. Okay. Okay, so there we go. Okay, run that again. And there we go. That worked. I've mocked out the collaborating object pretty succinctly by using @mockbean. Okay, so now I've got the service. It's up and running. It's green. I think we should build a client, right? We should build a client. So let's go back to start.spring.io. We're going to build a client, and we're going to use Spring Boot 2.2.0 again. We're going to call this a consumer, okay? And we're going to bring in the latest and greatest version of Java, of course, and we'll bring in the stub runner and Lombok and the reactive web support. All right, there's this. And we're going to hit generate. And we'll open this up just as before in our IDE. Okay, so now we have a consumer, and all we want to do in this consumer is confirm that when we load the application, when we create a client that can talk to our service, that it successfully marshals the JSON back and forth, that it makes the right request, and so on. And then we could distribute, presumably, this this client library. We could distribute that to other people in the team and the organization, and they would have this sort of blessed thing they could use to make calls. Okay. So what I'm going to do is I'm going to just create a regular Spring Boot test. This loads the entire Spring Boot application context, but in this case, it's not such a big deal because we only have one little object, right? So I'm going to create a reservation client. Okay. Create that class. And it'll be a class that's going to be a Spring Bean, of course, so @component. And we're going to use that in the application context. We'll say this.client.what? Get all reservations, I'd say, right? So get all reservations is going to return a flux of reservations, right? So here's the results, like so, and so, and so, okay? So you can see there's a lot of things wrong with that. First, I don't have a method called get all reservations. I can define that in the production code. Here we are. Get all reservations. Okay. Okay, there's this. And we'll say class this, and we now need to return that data. So for now, let's just return null just so we can proceed with a test here. Reservation Good, that seems like it's working. That's working. And what I want to do is I want to verify that when I call this method, I get a response back. So I'll say step verifier.create reservations. I'm going to expect that the next result that comes back will have a certain shape. I'm going to say that the name, reservation name, equals Jane, and reservation get ID is not null. And of course, here we've got another problem, right? We've got another thing that isn't working. Obviously, we've got red in the test. So I need to go back and implement these types. I need to make sure that those methods and those fields exist. So let's actually get to that, okay? So private string reservation name and ID, all right? Data, all args constructor, no args constructor, there we are. There's this, and we're gonna return the results. Now, if I run this code again, we can already imagine some problems. First of all, I need to make the actual network call. Let's see what that looks like. How can I make the network call without the web client? Okay, so I will go ahead and implement the client, or inject the client here. I'll inject it into the constructor, which I can do it like this. I want to run this test here. Now, in order to make this work, let's see, we know this is going to fail and return null, so let's just get ahead to that. I'm going to say get the data from here. Okay, retrieve the body and turn it into a publisher of type reservation.class. There's my HTTP call, my network call over the wire with the injected dependency. The dependency itself has to be provided. I have to actually define a bean of type web client somewhere, so I can do that here. Web client.builder, return builder.build. Okay, so just building a reactive, non-blocking HTTP client that we can use in the code. We can run this test again. Here we go. And you can see our problem, right? We've got a bit of a problem, don't we? If we run this code as it is right now, it connects, it tries to connect, but it fails. It says connection refused. And this is where we have to have just a brief moment to talk about culture. Now, I don't know what it's like where you are, my friends, but I am from San Francisco, in Silicon Valley. It is very common for people who work in an organization to be friendly to new employees, new hires, people who have joined the team. It's very natural to want to wish that person, whoever she or he is, a good day on their first day on the job. As a matter of culture, it's very friendly, for example, to say, it's very polite, for example, to say, hey, welcome. I hope you have a good day. Here's some coffee. Here's your chair. Please make yourself at home. Feel comfortable, right? It's a very polite thing to do, especially for a new employee on their first day. On the other hand, it is considered obscene, vulgar, very offensive indeed, if you were to say to somebody on their first day, here, come on in, here's a chair, here's some coffee, I hope you have a good day, and in order to test your code, you need to deploy this Kubernetes cluster. There's nothing more offensive, nothing more vulgar for most people in Silicon Valley. People have been known to quit under such hostile terms. Nobody wants to be told that in order to test this simple client, I need to deploy a whole Kubernetes cluster and all the backend microservices just to be able to test it, right? This is where people get tripped up with microservices. You see, the traditional testing pyramid dictates that at the bottom of the pyramid, at the bottom of the triangle, you have the bulk of your fast feedback unit tests. These fast feedback tests are meant to be lightweight. They're meant to be really quick. They're meant to give you a confidence that as you move forward and you make changes, you're not breaking things. There may be some small breaks, but the 80% bulk of your application should be just fine, right? You might have some small breaks, but you catch those smaller breaks with the fewer and relatively much more expensive end-to-end and component tests and integration tests and smoke tests and speed tests, etc. Those much fewer, much more rare tests are at the top of the triangle. There are fewer of those kinds in a typical application. But here we are doing microservices. And now the interaction between one service and another, really one component and another now, is over the network. And so by definition, they become integration tests. And this is problematic because it means we have to deploy everything just to be able to test any one little thing. Nobody has that kind of power. I bought a MacBook Pro back in 2018. It's a brand new MacBook Pro, and it has 32 gigs of RAM. And the reason I bought it was because I was hoping that I would finally have enough RAM to be able to run Slack and Chrome at the same time. And we're not there. We just haven't gotten there. But we certainly don't have enough to run a whole Kubernetes cluster, right? So I was hoping that that would be different, but it's just not the case. So what we need is some way to mock out that service. In the same way that we used mock bean in the HTTP test, we need to mock out the network HTTP service. So let's go back to our test here, and let's look at one way we can do that. One way we can do that is with wire mock, okay? So I'm going to bring that in, and I'm going to configure wire mock, auto configure wire mock, and the port will be on port 8080. So I'm going to use wire mock to create a mock HTTP service, okay? And the way you do that is you say wiremock dot stub4 wiremock dot get wiremock URL equal to reservations, okay? And we'll return wiremock a response dot with status HTTP status dot okay dot value, okay? So there's this. I don't need val. Okay, goodbye to that, whatever that is. Okay, good. And we're going to say when somebody calls reservations, we're going to return a response with a status, with headers, HTTP header, content type, media type, access application value, and with body, and the body will be a string. Okay, the body is a string that that just we're going to provide JSON that looks like the response that's being expected here. Okay, so var JSON, and this is where I can't wait until multi-line strings becomes a GA feature. But in the meantime, I'll just do this the old-fashioned way. Okay, so I'm going to create a JSON object inside of a JSON array, and inside the object, I'm going to create an attribute. Okay, there's one attribute, and there's another. So the first one will be ID. The value will be 1. The second one will be reservation name, and the value will be name. Okay, there we are. There's the JSON. So I'm going to return that JSON here, and that'll be the mock response. Now, this is the third-party WireMock API. It wasn't created by the Spring team. It's workable, right? It's okay. I'm not a huge fan of super chained methods like this, but hey, it works. So consumer application tests. Okay, so there we go. We made the call. What happened here? Oh, it's got the wrong unit type. It's got the wrong test type. So get rid of that, get rid of this, and get rid of that one. I should be using the JNet 4 test, not the JNet 5 one. Okay, restart. Okay, so there we go. That worked, right? We got a green client, we have a green service, and surely that's enough, right? Surely we have everything we need to be able to go to production. Unfortunately, I think we're missing something quite critical. I've just noticed that we've got a particularly bad issue. If I go to my producer on the server side, the API side, if I go to the reservation entity here, reservation, you can see that the attribute is called name. On the consumer side, however, I've been using reservation name. And so while both sides are green, these things would never have worked in production. They would have broken in production. And so in order to catch that tiny little typo, that little that one little slight change that seems innocuous and innocent enough, in order to have caught that, I would have had to use a integration test, and that would get me back at the first square, and I'd be back on the first place where I was trying to avoid. I'd need to deploy my Kubernetes cluster just to be able to interact with that. This becomes problematic. I use WireMock, and I like WireMock. WireMock's a great API, especially for third-party APIs that are stable. In this case, we are in a team, we're in an organization, and there's two different teams. APIs move very quickly. You can't rely on one being the same as the other. You can't rely on there not being any volatility from one day to the other. So you need to know that things will change. If things changed in a monolithic application, you have the compiler to tell you that something is broken, something has changed. The type on which you were depending has now changed in some way that stops the process from compiling. You have no feedback now. There's no guidance here that the network API to which we're making this request has broken or changed in some way. What we need is some way to have that confidence, the confidence that a compiler gives us in a monolith, and have the same fast feedback loop that we get by mocking out the API, right? Or by mocking out a collaborating object. Contracts give us a way to do that. Contracts are a mechanism that captures a particular interaction with our network service. It says, I'm expecting a request that looks like this, and I produce a response that looks like that. This contract is turned into, by a compiler plugin, is turned into a test that runs at build time. That test validates the producer. If that test works, if the test is green, then that contract gets installed into my local Maven Artifactory repository. Okay, there I can consume it from the consumer and use it to stand up a mock HTTP API, one that is driven and informed by and based on the contract that we used in the producer side, the one that got turned into a test and that was validated, that was used to validate the producer side. So one contract will be it'll be a shared artifact between producer and consumer. It'll only be used in the test time. So this is nice because you don't have to do the validation at runtime anymore, right? You won't even get into production with this mechanism. The test will fail and it'll stop you from going to production. So let's create a contract. You can see that in my directory for the producer, I've got source main resources contracts, and I'm going to create them in this producer directory. They don't have to be though. They could be in a shared directory between the producer and the consumer, right? They could be in a mutual third-party project, or the consumer could drive them. It's really sort of a matter of how you want to approach it, but I'm going to create them here. So I'm going to create a file, should return all reservations.groovy, okay? And here, I'm going to create a contract. I'm going to use the Groovy DSL. There's a lot of different DSLs that you can use. You can use Kotlin, you can use Java. There's even a YAML one, which is sort of, I wouldn't, I'm not sure if that's a thing I want to use, but hey, you can do all sorts of things. Should return all reservations. This is the description of this interaction. And you can create one contract or millions of them, right? Or thousands. It doesn't really matter. They're super lightweight and they're cheap. And you can create, they're fast as well. So you can create as many as you need to capture all the different interactions between services and components in the system. In particular, you can use them to make sure that you don't break assumptions. So if you change the API and you move to 1.1, you want to make sure that all the clients that are depending on 1.0 still work. And these contracts can help you capture any such regressions. So here's my contract. I'm saying I'm expecting a request that has this following structure. It's an HTTP GET. I expect that the request will go to URL/reservations. I'm expecting that the response, right? Response looks like this. I'm expecting that the status code will be HTTP status. Okay, that value. I'm expecting that the body is going to have I could either put a string or an object literal. And I'm expecting that the headers, I'm going to come back to that body in just a second, but for now, I'm expecting also that the media type header, or the content type header, reflect my expectations there. Now, let's talk about this body a little bit. This body could be a string. It could just be a JSON string if you want. That's fine. But I like Groovy. Groovy has a nice syntax. So I can actually say, hey, Groovy, I want to describe a list like this. That's just a list. And I want to have an object literal. And it's sort of like a map, right? I can just say ID1 and name is equal to Jane. Okay. So there you go. So now I've actually got this. It's not quite JSON, but it kind of looks like JSON, and it gets turned into the right representation at runtime. And there you go. That's our contract. Now this contract is going to be turned into a test. It's going to be turned into a test at compile time by the Spring Cloud Contract Maven plugin. Now, because we're using JNet 4, we need to get rid of that. Because we're using reactive, we have to be explicit. We have to say this is an explicit configuration. And this is going to be turned into a unit test. It's going to be turned into a class called contract verifier test.java. And that test is going to be based on the properties in that contract. Well, that contract, of course, is going to make an HTTP request to our HTTP service. Well, you remember what we had to do for the HTTP test here, right? We had to mock bean the reservation repository, and we have to, we have to have Spring installed as well. We have to start up the Spring application context. So what this contract needs is a base class. So I'm going to create a base class. You can create one base class per contract. You can have one shared base class for multiple contracts. You can have a pattern so that if it says foo in the contract, then you also use something foo test for the base class or whatever you want, right? But I'm just going to create one base class for my entire application since I've only got one contract. My base class is just going to be a Spring Boot test, right? It's going to start up. I'm going to tell it to run on a random port. I'm going to tell Spring to run on a random port. There's two different ways you can do that, like this or that, or like that. So you can pick either one. I'm going to run this with the Spring runner, of course. And I'm going to create a before class, a before method, to set up the objects in the object graph. So at mockbean private reservation repository. And I'm going to say mockito.when this.reservation repository.find all. Then return a flux of reservation. One Jane. Okay. There you go. So there's our basic setup. Now, the only other thing is that since we're running this on random ports, we need to tell the test mechanism, rest assured, which is the engine underneath everything, we need to tell it where to find the port, which port to find the service on. So we're going to inject the test port into the code, and we'll tell the test runner, the test machinery, what the base URL should be. So localhost. Okay, and there you go. That's the entire configuration in our base class. We need to tell our build file about that here as well. So we say, okay, base class for tests, com example producer base class. And with this, we can run the shell, okay? So there's our producer, Maven clean package, or let's just try doing Maven install, because I want this to, if it succeeds, I want it to install into my local repository. All right, so that worked. Let's see what it did. So it compiled everything, and it ran the tests. We didn't see it fail, but there's actually a class. You can see find iname contract verifier test.java. We can cat that file here. This file is a class that was generated for us by the compiler plugin. And it says that it's going to extend our base class. That's the one we told it about in the config file, right? It says com example producer base class. It extends that, and it says, okay, given a request to / reservations, expect the status code to be 200, expect the response to be application JSON, expect the JSON body to come back and have an ID attribute that's equal to 1 and a name equal to Jane. So we can, of course, fail this test again. We can break the contract to prove that everything is working. That's a very good idea if you're unsure about whether things are working too well. So let's say that this is going to be, we're going to break the test, okay? I'm going to make it Janet. That contract should now fail. So let's try it again. Okay, so there's the bug, right? We broke it. As you can see, it says contract verifier test should validate should return all reservations is no longer correct, right? There's an error in there somewhere. It says parsed JSON equals Jane doesn't match blah 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 equals Janet, right? So that's a problem. We fixed the bug, so we know that it's working, and we've installed it. And when we installed it, what did we see? Well, when we installed it, it ran all the unit tests. It compiled everything just like normal. It converted our Groovy script into a Java test case, and it ran that test against our code base. It actually called into our HTTP service, into the HTTP API. And since the base class for HTTP API is returning a JSON object, a publisher with an ID of 1 and a name of Jane, then it's working fine, right? We know the service itself is working fine. This Groovy test class, this contract, in a sense, actually does most of what this does. So we don't need this HTTP test. You can do this. You can keep the HTTP test, and it's actually also possible to use the HTTP test to create the contract for you. You can do it the other way around. You can actually have the test generate the contract, whereas in this case, I use the contract to generate the test. Either way, having both of these might be redundant. You don't need to have both. When it successfully installed, what I got was a jar, of course, no problem. I got a pom.xml, okay, normal. But I also got a stubs jar. And this stubs jar contains a configuration file that's based on WireMock that was installed in my local M2 repository. Now that that's there, I can use this in my test. I can go here. I can comment out on the consumer side. I can comment out this auto-configure WireMock, and I can say auto-configure stub runner. I'm going to say I'm going to run it on. I'm going to say use the stub runner to find in Maven in my local M2 repository the group ID called com example, the artifact ID called producer, and find the latest version. And when you find it, run a mock HTTP service, just like we did with WireMock, but based on the contract instead, and run that mock service on port 8080. Okay. I could tell it to find it in my class path if I have that. If I can actually add a snapshot dependency to my local build. I could also have it in my artifact tree or my nexus or whatever. But for now, just say local. Okay. So there's my auto configure stub runner. With that in place, I don't need this anymore. I don't need WireMock explicitly. This will just do it for me. Okay. So here's the consumer application tests. Start it. Okay, look at that. I got a null pointer. Okay, that's what we wanted, right? We want to know that the marshalling is not going to work. So where's my null pointer? Here we go. It says reservation name equals null. Well, of course it does, right? That's the wrong property type. So we need to change the entity here. The DTO, the reservation type here, needs to be name, not reservation name. We know that now. Somebody, me, made a mistake and did the wrong thing. It was just a simple accident. I didn't mean for it to happen, but it happened, okay? Okay, there's our contract. It worked. We actually stood up a mock HTTP service that lived for the lifetime of this method, right? It lived for that method. It was created, basically before context loads was called. And for that time, if you were fast enough, you could go to your browser and open up localhost, whatever, some port, and then find the actual JSON that was being created there. So it's an actual network service. It's just super lightweight. It doesn't cost anything to run it. And it's based on WireMock as well. Behind the scenes, it's using WireMock, but it's using WireMock based on a contract definition that you installed on the producer side. Now, some people will want to be able to use that contract for their own purposes. Maybe they're not using Spring for their particular code. Maybe they're using, maybe they're building an iPhone application or an Android application, in which case they don't have the ability to say auto configure stub runner in their iOS Swift Objective-C code, right? So for them, we have a jar that you can use. You can just distribute this in the organization. So here, okay, bin, Josh bin, Spring. So there's a jar you can download. I've got 3 different versions of the jar here. You should just get the latest one, and you can use. They're all pretty much the same. Here's a script that I'm using. The script says Java -jar, run it on port 8090, run the application, not the mock web server, on 8090, and then use the stub runner boot jar 2.111 I want to work offline. I want to find my local Artifactory, my M2 repository, not Artifactory or Nexus, and I want to run the Maven. I want to resolve the stubs jar using these coordinates, just like I did in the annotation. If you do that, then now somebody else who's building the iPhone client or whatever, they can go to localhost 8080/reservations here, and there's the data. It's the data that we returned from our contract, right? This is the stub data that we returned. It's not real data. Nobody had to deploy a Kubernetes cluster to get this. I'm not deploying a message queue and caching and security and all that just to get this. It's just a simple endpoint that's based on the contract that I deployed. This is how you help people make themselves feel a little bit more comfortable and get to production faster. I've just shown you the absolute basics today, my friends. I wish we had a lot more time. I've only shown you HTTP, but you have to keep in mind that messaging is also a great use case for contracts, because as soon as you've got a producer and a consumer exchanging messages over the network, the common ground is the exchanged payload, right? So that contract needs to agree, that payload needs to agree, producer and consumer need to agree on that. You can use Spring Cloud Contract to mock out messaging-based interactions as well. So if you're using Kafka or RabbitMQ or whatever, you can mock that out very easily. You can use Spring Cloud Contract also to support packed files. Packed, our consumer-driven contract. It's another consumer-driven contract framework. We also support those. You can use Spring Cloud Contract with other languages, as I mentioned earlier. And there's just a lot of other stuff you can do. You can even mock out service registries, for example. So if you want to do resolution of a service in a service registry, but you don't want to have to stand up a whole Zookeeper or console or Eureka or something like that, you can do that. I want to thank you, my friends, first of all, for indulging me. I'm sorry that I missed that earlier performance, and I am super grateful that you were able to come and hang out this time. I'm happy to answer any questions, and obrigado. Elder, back to you, my friend.
Wow, thank you, Josh. Well, we didn't have any question on the chat. I don't know if you want to say some last thought or hit or console or something. If not,
nope. Thank you so much.
Okay. So guys, thank you very much, and I hope you enjoy, and see you next time. Bye-bye.
Bye-bye.